Hey everyone, welcome back to Everything Mathematics. In today's lesson, we are going to once again apply a lot of our knowledge when it comes to trig. That means identities, the unit circle, in order to solve trigonometric equations. But in order to start, we are going to assume some prior knowledge. We are going to assume that we feel very familiar with this Pythagorean identity, these reciprocal identities, the one that says that secant of x is equal to 1 over cosine x, and with the double angle identities, particularly the one for sine of 2x. Another thing that I want you to keep in mind is that there are some helpful tips that we can implement whenever we have to solve an equation. So for example, if you're given an equation and the equation has secants, cosecants, and cotangent, you may want to reconsider re-expressing that in terms of sine, cosine, and tangent, the basic trig functions. If your equation has denominators, you may want to consider simplifying by getting a common denominator first. And if your equation consists of expressions that can be substituted with other known identities like the Pythagorean identities, you may want to consider that. And I'm going to show you in the examples that I chose to work here for you today will implement some of these techniques. And then another thing that we want to keep in mind is factor. Whenever you can factor, try to factor. It really helps out. Let's take a look at the example. So here we have the very first one. They're asking us to solve the following equation, this one right here, within the interval 0 to 2 pi. So when I look at this equation, I do see that I have a square, which is good, already kind of signaling possibly factoring, but I'm not ready for that yet. You know, whenever you have an equation, you want to make sure that you have the same variable throughout. If your equation is in terms of x, you only want to have x's in there together with constants. Here, I have my expression. The left side of my equation has cosine, but it also has sine, and kind of that creates complication. So let's go ahead and see how we can possibly do some sort of substitution so that we get the same variable on the left side. For example, I already see that I can do that by perhaps substituting sine squared x with 1 minus cosine squared x. And this comes directly from the Pythagorean identity. So if we do that, we are going to have 2 cosine x plus 1 minus, I'm going to put brackets here, and now I will substitute 1 minus cosine squared x in place of sine squared. And that's going to be equal to 3. And this is nice because now, if you notice, the only variable that I see there is cosine x. Now it's consistent. So we're going to go ahead and distribute this negative first, and that is going to give us 2 cosine x plus 1 minus 1 plus cosine squared x equals to 3. Then simplifying, notice how we can cancel the ones, and I'm going to even start already arranging everything in descending powers. So we're going to have cosine squared x plus 2 cosine x, and I'm going to even bring the 3 to the other side so that we leave 0 on the right side. Remember, when solving quadratic equations, what you want to do is you want to bring everything to one side and you want to have 0 on the other side. And that's what I have right now. Now I'm thinking here of factoring. Sometimes it helps to replace cosine with another simple variable like u and then factor. Imagine that I go u squared plus 2u minus 3 equals to 0. It's so much easier for our brains to handle this quadratic, to factor it, and then at the end we can bring cosine back. So then you would have u times u plus minus, and then over here we would have 1. No, actually we want to have 3 and 1. Nice. So now now that I have factored the quadratic, I will bring back the expression for cosine. So I will replace u with cosine is what I'm trying to say. So here are my two factors. I'm going to have here cosine of x plus 3. And then over here, I'm going to have cosine of x minus 1. Okay, so that's looking very good. Now, that means that we can set each factor equal to 0, nicely like that. And over here, we're going to have cosine of x minus 1 equals to 0 as well. And then we can simplify. We can isolate the variable. So cosine of x is equal to negative 3. And here, cosine of x is equal to 1. So now we have to think, well, is it possible to solve this equation? And here I want you to remember that this equation right here has no solution. There is no solution. And that is because cosine is always between negative 1 and 1. So cosine of x is always less or equal than 1, but greater or equal than negative 1. So no solutions there. And then for this one, cosine x equals 1, well, you can use the unit circle, or you can use the sinusoid, the graph of the parent function for cosine. I'm going to use the graph here just to practice with graphs a little bit more. So this is one cycle that goes from 0 here all the way to 2 pi. And I want you to notice that cosine of x is equal to 1. You see right here at 0 and at 2 pi. So I'm going to make those dots right here green, right here and right here. So then I conclude that the values of x are going to be 0 and 2 pi. So these are the solutions for this equation within this interval right here, 0 and 2 pi. In the second equation, they're asking me to solve the equation that says that sine of 2x is equal to the square root of 2 divided by secant x, and then they want the general solutions at the end. So let's go ahead and try to simplify. Remember in the pointers that I was giving you earlier when it comes to solving equations, I was saying there, well, if you notice that you have secant, consider changing that into cosine. And I'm going to go ahead and do that. Also notice that we have the sign of a double angle. So think about double angle identities. Okay, so with all that in mind, on the left, I'm going to use the identity that says that sine of 2x is equal to 2 times sine x times cosine x. That's on the left side. And on the right side, we're going to have square root of 2 times cosine of x. Because if you remember, secant is equal to 1 over cosine. So if I have 1 over secant, that means cosine. Okay, much better. Now, As always, don't try to divide by the variable. I know that a lot of you are going to be tempted to divide both sides by cosine of x. We need to be super careful in mathematics with actions like that. If you divide an equation by a variable, you may potentially lose valuable solutions. So this is why you don't want to do that unless you have more information. But if not, don't divide by the variable. Take, let's say, this side and move it over to the left side, and then try to see if you can factor anything out. So I'm going to take the left side, I'm going to leave it there as is, and we are going to subtract this expression from both sides. So then we're going to have minus square root of 2 cosine of x equals to 0. Now I want you to notice that we have here a common factor. So I can take cosine x and I can factor that out. So now I'm going to have 2 sine x minus the square root of 2 on the left side. So nice. Now from here, I can say that cosine x is going to be equal to 0, or 2 sine x minus square root of 2 equals to 0. So let me continue simplifying this expression right here. I want to have sine x completely alone on the left side. So sine x will be equal to the square root of 2, and then we're going to divide by 2. So that's what we have. So now we have to find the solutions of these two smaller equations. So where is cosine x equal to 0? Again, you may use the unit circle. I'm going to use the sinusoid again, the parent function for cosine. And you notice that it is equal to 0 at pi over 2. And is also equal to 0 at 3 pi over 2. So practically pi units later. So then I can conclude here that the general solution for the first equation will be starting at pi over 2 and then adding or subtracting pi n, where n, I'm treating n as a natural number. And the reason why, again, we have multiples of pi, we're adding or subtracting multiples of pi, is because the distance from pi over 2 and 3 pi over 2 is precisely pi. So that's what we have there. Now for the second equation, we have that sine x is equal to positive root 2 over 2. So then I'm going to use kind of a unit circle approach here. It's a little bit easier since I now have this fraction root 2 over 2. And I will identify the quadrants where sine is positive. Sine is positive in the first quadrant and in the second quadrant. And by noticing that sine is equal to root 2 over 2, I am hoping that with your knowledge of the unit circle, you realize that the first angle here will correspond to pi over 4. Pi over 4 is the only special angle whose coordinates are root 2 over 2. So once we know that we're dealing with pi over 4 as the special angle, then this angle in quadrant 2 will now be 3 pi over 4. And as a result, the general solutions will be x equals pi over 4 plus minus 2 pi n. So this general solution will give you all the solutions that are coterminal with pi over 4. And then the other solution will be for the ones in quadrant 2, 3 pi over 4 plus minus 2 pi n. And now here we make a statement that n is a natural number. So then all the solutions are going to be the general solution for the first equation and then the general solutions for the second equation. All right, everybody. Please know that I am assuming at this point that this is not the first time that you're talking about general solutions. So I am kind of assuming that you already have some sort of knowledge when it comes to that. I'm also assuming that you have knowledge of the unit circle and that I didn't draw that unit circle, but just imagine that you do draw your circle right here. After a while, we stop drawing the unit circle and we just focus on the terminal sides of the angles. And I'm also assuming that you have already basic knowledge of the trigonometric functions, like the parent function for sine and the parent function for cosine. I hope that you found this lesson helpful. Remember, math is all about practice, so keep practicing, keep solving other equations, and you're going to see that your skills and your speed will gradually improve. Until next time, everybody. Bye.